Okay, everybody, welcome to another session of our Algebra 1 virtual tutor. And in this section, we're going to look at objective 26. Now, in 26, we're going to do something called write the equation of a line. So we're going to end up with an equation graphically that will be able to represent a line. And we've done some of this in the past with mx plus b. Just last section in objective 25, we used y equals mx plus b to talk about parallel versus perpendicular and their slopes. So now we're going to kind of put all of this together and be able to do an algebraic representation of a straight line on a graph. And that's exactly what we're talking about here. The algebraic representation of a straight line is the equation of that line. And we've worked with this all year. It's just a matter now of being able to write it. And we've done it graphing, taking the equation, graph it. This is basically the other way around. Now, there are three different ways that we can write this equation depending on what we're given. And in this section, we're actually allowed to do several different ways to get the same answer. What you end up choosing is going to be really your personal preference. I'm going to show you a bunch of different ways to solve these problems, and you're going to have to choose which one works best for you. So, slope-intercept form is the form that we'll use in this course most often. Almost all of your answers will be in slope-intercept form. So if I say write the equation of a line, your job is to write the slope-intercept form. And that's what you've been working with all year already. And it's y equals mx plus b. Okay, it's ideal, I guess not slop, but that should be slope. Careful there. It's ideal when you're given the slope of the line and the y-intercept. And in it, we know from our graphing days that m is my slope and b is my y-intercept. And if you have those two values, we're just going to plug them in and solve them. So, our next form is a little different. It's called point slope. And what that is you can see there's quite a few differences. The slope actually remains the same. M is still slope. But the other point is actually another point on the line. And actually, all point slope is the slope formula rewritten. You can see I've got x1, y1, and these are really just x2, y2. And all they've done is take y minus y over x minus x, change in y over change in x, and rewrite that into the form of an equation. Hopefully what we can see is that both of these are just the same numbers in different forms. Now, this is great. x1, y1 is a point. It's a coordinate. So this is the x value, and this is the y value. Of a given point. But what you would have to do in this case is once you write it in point slope form, you'll have to solve this for y. So it has some issues. Now, standard form is not a form you would actually ever use. Standard form actually comes into play a lot more in Algebra 2 or higher level courses, where it's simply the x's and y's are all on one side and there's no fractions anymore. So they've done some algebra to get x's and y's on the left side, and that's equal to whole number. A, B, and C are still numbers, but they're all whole numbers. There's no fractions in there. Okay, so your job is to pick and choose. Now, certain situations call for one of these first two equations versus slope-intercept or point-slope. If you're given a graph, you want to use slope-intercept because you can pull out the y-intercept and the slope right away. You don't need to do anything. So as I list out my steps here, I'm going to say, let's recognize, pick a form. So I'm going to choose that I'm going to use y equals mx plus b, and that's my first step. I'm given a graph. Let's use the proper equation for the job. Now, steps 2 and 3 then come directly from that because I need to find the slope and the y-intercept. So slope is rise over run. Now, this graph is very difficult for me to see here. So I'm going to do my best to pull out some numbers here. Hopefully I get, yeah, that looks pretty good. All right, so when I go to do my slope here, I'm counting that this rise is 2 and the run is 3, and that's a negative slope. So my slope is negative 2 over 3. Now I also was able to verify that my y-intercept is right here, and this is the y value of the y-intercept, which is 1. And I don't like the fact that that was a different color. That's going to bother me. So there you go. Now my last step is to take those values that I found and write my answer. All right, so you can see on number 2 we have a similar graph, and what I'd like you to do is pause the video for a second. Try this on your own, and I'm going to pause for a second, and I'll have the answer up in a second, ready for you to check your work. So try this on your own, and in a couple seconds the answer is going to pop up here. Okay, so you can see here I found that my slope was up 1 over 4, and my y-intercept was 2. Again, the y value of the y-intercept is 2. So my equation is 1/4 x plus 2. So this is when we're given a graph, and that's your first key piece of information. Can we write the equation when given a graph? The next two are much more algebra intensive. In this one, I'm only given 2 points. And really, I'm out of luck at this point. I don't know slope. I don't know y-intercept. I've got nothing. So regardless of how we go about solving this, I need slope first. Both of my forms, either slope-intercept or point-slope, say I need slope. So my first step is to find the slope. Well, how do we find slope? We use slope formula. Let's remember. Okay. And let's go ahead and plug in some values. And I get a slope of 1/5. Okay. Now, the choice now ends up being yours. Do you want to use point slope or do you want to use slope intercept? I'm going to recommend point slope. In fact, it's the only way I'll ever solve it when I'm given a point. The other way, trying to fit slope intercept to make this work, is more hassle than it's going to be worth for you. So I'm going to use point slope. Well, here's why I like it. Point slope is simply that equation rewritten. I'm going to take this whole thing and move it to the other side. So really this x2 minus x1 is just going to come up there. And actually, this is done. This is point slope. I can change this and do our symmetric property. And flip it around. And the only difference is that instead of x2, y2, I just call that x and y, and I don't plug anything in. So why do I like it? Because now I'm just about done. I'm not going to plug anything for that y2, but I am going to use y1. And I already found that y1 right here was -5. I know my slope. And my x1 right there is -2. So because I'm already using slope formula, I don't have to deal with anything more. I mean, it's literally the same exact formula. And that is going to be my step 2. Now I'm going to clean that up. Minus and negative is a positive. Like so. And that's point slope form. Unfortunately, you're never going to relieve that form. Your answers are always going to be y equals mx plus b. So to solve that, and I'm actually going to write that down here. Well, I guess I'll put it here. You're going to need to distribute that 1/5 and then subtract 5 from both sides. So if you're having trouble with that distributive property, just make sure you use it in your calculator. That's fine. And what I end up getting for my answer is a little bit tough. But there it is in slope-intercept, which means that the y-intercept was never a clean number. That's fine. Okay. Oops. All right. So at the bottom here, you can see we've got another problem for you to try. However, I'm going to do this one because I want to show you all the options. There is another way to solve this that I do think is beneficial to you. And it's worth knowing now, and it's called a regression equation. And what a regression equation does is it is a calculator function. It's not a calculator function. You can actually do it by hand too. But a regression equation, let's actually write that term down. But it's an equation that best fits a set of data. If you go back and you think scatter plots and you had a line of best fit, it's the same deal here. Well, it turns out that there's only one line that can connect these two dots. So if I did a scatter plot with just 2 points, I'm literally going to get the exact same line that connects those 2 points. The reason I bring this up is because your calculator will actually do a regression equation for you. So to get that, let's bring our calculator out. You're going to hit the stat button because this is a statistical function. And we're going to go to edit. And what we want to do is enter each of these points in here. This is my x column. This is my y. So I'm going to do the x values first, and then the y values second. And it's very important that these get in here correctly. 2, -4, -1, 5. Now, that's in there. We can kind of quit out of that. We're good. We're going to go back to stat. See how I hit stat. And we're going to go to calculate. And these are all of the regression equations that we can do. This is a good point to get used to this menu anyway, because we'll use this a little later on as well. But right here, we want a linear regression. You're actually going to do a quadratic regression as too at some point, but I know I want the equation of a line, linear, and look at that. It actually gives us the entire thing. Let's go ahead and copy that for you. Paste, like so. So I'm going to try to talk and do the same thing, because I'm going to put all of this here. This saves you a lot of energy. Now, it has some problems. The first problem is that it works great. Oops. It works great as long as x, a, and b, in this case, are whole numbers. In this case, they were. This is fine. The problem you're going to run into, go ahead and get one more screenshot, is that most of our linear equations are not whole numbers. And that means, there we go, that means these will end up being decimals at some point. That's great if you can convert from decimal to fraction. For instance, I'm going to go ahead and type this one in just so you can see it. And I'm going to do it off screen here. Excuse the bell. Okay. So here's what it looks like when these are fractions. So if you get decimals like this, you can't tell me that the answer is 0.2x minus 4.6. That won't work. You'd have to actually convert these to fractions, which your calculator will do as well. We would just quit out of this. Oh, I'm already quit out of it. We would type in 0.2, math, switch to fraction. There's my 1/5. And we do -4.6, math, convert to fraction. There's my 22.23/5. So you can see that this will work, but you need to be very careful. And imagine what happens when this is an irrational number, a repeating decimal, not irrational, but a repeating decimal. Then you're going to have even bigger troubles converting to fraction. So I show this to you as an option. You'll see I don't use the calculator as much as maybe you guys would want to, because I think the algebra ends up being easier. You just have to kind of work with it. This is a great option to check your work though, guys. So if you have access to the calculator, it's a fantastic way to check, are you correct? Because I'll tell you, it's a lot easier if you already have this. It's a lot easier to verify that those fractions are the decimals that my calculator had given me. I do leave the choice up to you all. Now, the third type of problem here, you can see I'm not given 2 points. This takes the calculator off the table because I don't have 2 points that I can do a regression equation on. This is actually tailor-made for point slope because it has point slope. And that's exactly what we're going to use. We're going to plug this right in. Remember that my point slope formula is that, and we have all of our points. y1, here's my slope, and here's x1. And then we want to clean up minus the negative and just make that a positive. Now remember, we want our answers in slope intercept, so we always want y equals. So our job distribute this 1/2. And then add 3 to both sides. There's my answer. And unfortunately, there wouldn't be a great way to verify this in your calculator. The one thing you could do is you could graph this and make sure that this point or this equation does have this point on it. And that would be a good way for you to tell, okay, that at least for probably is the same thing. Okay, just like before, take a moment, try this one, pause the video here, and when you're ready, I'm going to put the video, go ahead and play it back, and I'll have the answer up here for you in a second. Go ahead and pause now. Okay, so you can see here I got an answer of negative 3x plus 5. And I did want to show you, here's me typing this into my calculator, negative 3x plus 5. And here's the graph of that line. Excuse the bells again. Now, to verify this is correct, I'm going to go to my table of values, and I'm looking, is 1, 2 a point there? And yeah, it is 1, 2. So I know that this is this. Now, I'm not 100% sure, but as long as I get that point, I'm probably okay. Okay. Whoops. And as you see, there we go. So, 3 types of problems, given a graph, given 2 points, or given a point and a slope. And from there, your job is to simply write the equation. Make sure it's in y equals mx plus b. All right, so that'll conclude this video. And again, if you have any questions, feel free to rewind it or check as we go. All right, we'll see you soon.